In this video, we're going to start taking a closer look at transformations. So what is a transformation anyway? Well, a transformation is a rule of sorts in which you take a figure and you change it. So there are two types of transformations. There are similarity transformations where you can make the figure either bigger or smaller, and that's called a dilation. And there are congruence transformations. And in a congruence transformation, we do not change the size of the figure, we just move it. So we're going to start off by looking at our first type of transformation, which is a reflection. So a reflection is exactly what you think it would be. I'm sure all of us have looked in a mirror at least once. And so when you look in a mirror, what you see on the other side is your reflection. So a reflection is a transformation over a line called the line of reflection. So you can think of that line of reflection like a mirror. So I'm going to actually give you the very, very applicable, image here. So think of that as a mirror, but the mirror is actually the line of reflection. And think of this as you, and you're looking in the mirror. And what do you see on the other side when you look? You see yourself, same distance away. And I'm going to try to make this look the same, but of course it's never going to come out perfectly the same. But in this case, this would be the image, or actually that would be the pre-image, and that could be the image. It doesn't matter whichever one comes first is the pre-image, the other one is the image. All right. Well, the point is that you can create a reflection on any figure. It doesn't have to be your face or your body. It could be a triangle or a circle or a square. All right, so let's look at how we use transformations in geometry, or how we do transformations in geometry. So again, if this is our line of reflection, and I have a figure, let's say it's a triangle, and let's label it A, B, and C. If I have triangle ABC, then there is a triangle over on the other side, over here, which will be an exact reflection of that triangle. Now, in order to figure out exactly where that would be, a good idea would be to draw a horizontal, and it's horizontal so we can see the distance. So from B to the mirror is that, and if I had a ruler here, I would measure that same distance, and then I would put the image of B, and I'll call it B prime. And so I can do that for A as well. So basically from here to here, I would measure out on the other side. It would be about right here. And again, I wish I had a little virtual ruler so this could be more accurate. But for now, I'm just eyeballing it. You, however, would actually use a ruler. All right, and then we would do the same thing for C. Bring it across and measure it out. Make sure this length is equal to this length. And then you would have your image of C. And once you have all 3 points equidistant from the line of reflection, you can draw your reflection. And again, because I didn't have a ruler, this doesn't look quite right, but hopefully you get the point. All right, so let's look at it in a coordinate plane, and in a coordinate plane, you'll get a more accurate reflection. Okay, so in our previous example, our line of reflection was vertical. However, in this example, as you can see here, our line of reflection is a y equals 2. Hopefully you recall that a line y equals 2 or y equals anything is a horizontal line. However, not to panic, because this is treated in exactly the same way. The line of reflection works in the same exact way, and you will see as we go through the example. All right, so let's first plot the original triangle. So we have 0, 3 right here. That's J. We have -2, -1, so that's down here. That's K. And we have -6, 1, and that's L right here. And once we have those points, we can go ahead and join them and create our triangle, which looks like this. All right, So now, as we did before, what we want to accomplish is we want to make sure that we are looking at where our line of reflection is, and we are putting our reflection point on the other side of the line of reflection, equal distance from the line of reflection. So what do I mean by all those words? All right, so originally J was here. It's one higher than the line of reflection. So our image for J will go down here, one lower than the line of reflection. All right, I don't know if you can see this, so let me put it on something a little darker. And so J image is right there. Okay, so now we have the K, which is 1, 2, 3 lower than the line of reflection. So the image has to be higher than the line of reflection. It goes 1, 2, 3. All right, so we could also, as we did before, now use a vertical line to help us trace out where we want to be. So again, we are going to be 3 higher, 1, 2, 3, so right here. And again, because that's because the original was 3 lower. All right, and our L, our real L, is currently 1 lower than the line of reflection. So our image will be 1 higher than the line of reflection. So it will be right here. And now that we have those 3, we can join our points. And we see here our image looks exactly like the other triangle, just flipped. And the mirror is that line at y equals 2. And that's how you draw a reflection. Now, if you're anything like me, you're probably now asking yourself, well, are all my lines of reflection going to be vertical or horizontal? No, not necessarily. Most of the time, your lines of reflection will be vertical, horizontal, or you'll get the line y equals x. So let's look at a quick example of how to work with the reflection of y equals x. Okay, so in this question, we're being asked to graph the reflection of the quadrilateral below on the line y equals x. So hopefully we remember what the line y equals x is. So let's get that in our graph. The line y equals x is coordinates 1, 1, 2, 2, 3, 3, because of course y is equal to x. And it's just a straight line going down along that path. So I'm doing my best here to get this on the line. Awesome. Okay, so that's what the line y equals x looks like. In order to do a reflection on this line, we just have a fun little task to do, and that is to switch the coordinates. So the reflection of each coordinate will be x will turn to y, and y will turn to x. It is pretty awesome how that works out. So j prime will be 2, 2. You switch 2 and 2, you still get 2. K prime switched will be 1 and 4. We switched 4, 1, we got 1 and 4. L prime, we get -3 and 3. And finally, M prime, we get -4 and 0. Again, all we did is switch the order of these coordinates. We didn't actually do any calculations at all, just switch the order. All right. Okay, so now we're ready to plot our new points. So 2, 2 is j prime as well as j, so it overlaps there. K prime is 1, 4, which is up here. And L prime is -3, 3. So -3, 3, which is right here. And M prime is -4, 0, down here. And so now we have all 4 of our points, so we can join them together. And we get a perfect mirror image of our original thing, and the line of reflection is x equals y, or y equals x, and that's what it looks like.